All right, so continuing where we left off last time, remember we were doing inheritance, and that is the ability to create a superclass and a subclass so that everything in the subclass can inherit behavior from the parent, behavior and state. Generally what you do is you put a general behavior or state up here in the superclass, and then more specific functionality is located in the subclasses. So to continue, we were writing the various code to support stock accounts and savings accounts here. And it looks something like this. If I were to highlight all these three things, asset, stock, and savings, then we now have an inheritance hierarchy. Originally, the account number and the owner, which is a person, right, that was located in both of those, and there was no relationship between these classes at all. We took that common functionality, that common state, and we promoted it up to the superclass so that both the subclasses would now receive it as through inheritance. We do have some work still to do though, right? So for example, how can I even create a stock, or how can I create a stock? I want to create stock of, I don't know, Microsoft or Apple or something like that, right? Well, I need a constructor, right? And so let me go ahead and create constructor using fields. And if I do that, then great, but I don't see any way that I can say who owns this stock or what the account number is. Remember that that's in the superclass, all right? So let's go ahead and back up and let's undo that, right? And let's start with the superclass first because we need to be able to create assets, both stocks and savings accounts. So I'll go to constructor using fields. Oops, nope. Constructor using fields, there we go, right? And I want both of them, there we go. All right, and reformat that. Now you'll see that it actually broke something in the other classes. Because now my superclass has a constructor that takes an account number and an owner. Well, in the stock class, we have to specify those as well, right? That we can't just have a stock. The stock has to actually be an asset. Remember, it's an is a relationship. A dog is an animal. In this case, a stock is an asset. So who's its owner and what is its account number? So we can go over here to constructor using fields again. And in this case, it's going to take all 4 of them, right? Automatically. The account number and the owner. Now, what do we do with those? We end up calling the superclasses constructor. That's what this super keyword is doing here, right? And we might have seen that before when we automatically generated constructors, and we thought, what the heck is that? Well, now we know what it is. You're calling the superclasses constructor and passing on the account number and the owner so that you don't have to do it again here, right? Then we take the share price and the number of shares as well. We'll have to do the same thing over here in the savings account. Again, don't type, just go to source, generate a constructor using fields, and generate it, right? There we go. And reformat it. Now you also want to add in a bunch of getters and setters as usual. We'll start again at the asset set class up here, and we'll go ahead and add the getters, right? Again, prefer only getters because you prefer immutable objects. Let's go ahead and generate the getters, right? Get owner and get account number. And then we can do the same in the subclasses over here. Generate getters, just the getters, and we're done, right? Now, before I move on here, what about if I wanted the owner of this stock, right? First of all, do you see the owner at all in this subclass? No, it's in the superclass. Do you see the getter at all in this subclass? No, that's also in the superclass, but guess what? Everything gets inherited. Let me go ahead and create a stock now. Stock S is equal to new stock. I'll take care of a savings account here in a second. Of course, I'm going to need an owner for this, so I should have created a person first. Me equals new person. And I think it's last name, comma, first name, right? And that's good enough for now. And then the account number, I'll just say 1, 2, 3, 4, and then me, the owner, right? And the stock class, say that I own, I don't know what, 10 shares of Microsoft, whatever the share price is. Let's just go ahead and say that the share price is $120 and I own 10 of them. All right, there we go. Was that the order? Stock price first? Yeah, share price. All right, there we go. All right, now what can I do with that stock because it inherits everything from the superclass? Well, I can do things like, say, get the number of shares, get number of shares. And I can multiply that by get the share price to determine its value, right? So double value is equal to that, right? Now, this is not the way you do it. We'll come back and fix that in a second here. But I can use those getters now. Well, what about the inherited getters? Can I determine who owns it? So s.getOwner. Right? Now, do you see a getOwner method over here in the stock class at all? No. But it is inherited. Let me go ahead and highlight those 3 now. There's savings, there's stock, and there's an asset. Right? And as we fully flesh out this design, I start getting more and more stuff in this diagram here. There is the savings account constructor. We also have a stock account constructor over here. What about those getters? There they are. And then to look at the owner, right, the getter for the owner, right, you have to go to the superclass. The stock class still has that because it refers back to the superclass. Right? Great. Let's go ahead and do it for a savings account here too. Let's go ahead and source, generate getters, right? And all the getters, and we're done. There we go. All right. What else should I be generating? Anytime that you create a class, you want the constructors, you want the getters so you can get access to its data. What else is the basic operation that you're going to want? You're going to want to print it at some point, right? So let's go ahead and generate the toString method here. Also, you'll want hash code and equals, but you can do that on your own. All right, and I'll go ahead and generate this. Right, it doesn't look very pretty, but it's an asset. It tells me what the account number is and who the owner is. Okay, fine. What about over here in the stock class? Right? Actually, let's go ahead and go back to demo now, and let's go ahead and create a savings account as well. Right? Savings, SAV, right, is equal to new savings. And the account number here will be 5678, right? And I'm still the owner. And what else do I pass in for a savings account? Well, it's the balance, which is, say I've got $100 in there. Oops, $100.25. And then there's also an interest rate. Say that it pays me 3%, right? 3% interest on that stock, on that savings, right? What's the value of that savings? Well, it's just the balance, right? So double value 2 is equal to savings dot get balance, right? Okay, again, those two lines here, this is something that you should not do. We're going to fix that here in a moment. But I can use the getters here, and I can do all that. Now let's go ahead and actually print these out. System.out.println s and my savings account. There we go, SAV. Now, is it going to print out, what is it going to predict here? What is it going to print out? Well, let's go over to this stock class here, and do you see a toString method? I don't see one. Right? So, what's it going to do? It's going to go to its superclass first, the asset class. And what does the asset class do? It does have a toString method, right? And so it's going to print out asset, the owner, the account number, and the owner, et cetera, et cetera. And I'm going to have the same behavior for both of those, right? But neither one of those distinguishes whether or not it's a savings account or a stock account. So at this point, I'm going to go back over to my demonstration of my notes here. Remember that specific functionality is located in the subclasses. So if I want to make this a little bit more specific, I can go to the subclass and I can override that method. So let me go ahead and generate a toString method here. And this one we will do a little bit of work on it, all right? Generate that. It's a stock, and let's go ahead and also say that the account number plus this dot account number, get account number, plus the share price. Oops, I need a space in there, I think. There we go. Oops, nope. Undo. There we go. All right. Now let's come back over here to the demo, and you'll see that that account 1234 now has different behavior. It has more specific behavior. It doesn't look very pretty, but that's all right. All right, that's 120 shares or $120 per share, and the number of shares is $10. Okay. I didn't do it for the savings, but I can. Right. The savings is still inheriting that method in the superclass, but we can go ahead and override that by defining a toString method down here. And we'll go ahead and do that, and it looks nice enough. Now this is called overriding, right? In fact, there is a annotation. This is an annotation in Java that says that this method has been overridden from whatever it is inherited in the superclass. The superclass has this toString method. We're going to override that to provide specialized behavior. It's okay if you leave this off. It'll compile, it'll run, it'll be fine. But it's best practice to leave that in. In fact, the auto-generated code did that. Because what if you misspelled the method name, right? Now what we're doing is we're saying we're overriding the toString method in the superclass. There is no toString method in the superclass. The compiler says you're trying to override something that doesn't exist, compiler error, right? And there's something going on here, try to fix it. And so I'll go ahead and spell it correctly, and now it's back to square one. Once again, it is optional, but you should make sure that you do it. Yeah, oh, no, not a question back there? Okay. All right, so let's run this one more time to see that it is now changed as well. Savings, the balance is $100.25 and a 3% interest rate. Okay. All right, let's come back over here to the demo, and let me add one more, right? Asset, A, is equal to new asset, and the account number here will be ABCD, right? And I'm still the owner for it. That's a generic asset. What if I wanted to determine its value? Double value 3 is equal to A dot A's value, right? Well, what is the value of A? Right? If I just look at the asset class, is there anything here to tell you what the value of this asset is? No, right? So let's come back over here and let's try to solve this problem now, okay? I'm going to go ahead and get rid of that. Before I do that, though, I'm gonna appeal to the first two pillars of object-oriented programming. Remember what all the pillars were, right? We've gone through the three of them now. Abstraction, encapsulation, and inheritance. Let's focus on encapsulation. What was it? The grouping of methods, one of the parts of it, was the grouping of methods or behavior that act on that data, right? And that's something that I've been repeated over and over and over now. That sounds like a savings account thing. Where does it belong? In the savings account class. That sounds like a stock thing. Where does it belong? In the stock class. So does computing a value, does it belong here in the demo class? Doesn't sound like it to me. Right? If I want to compute a value, I should be able to ask the stock, hey stock, what is your value? Or hey savings account, what is your value? So let me come over here to the savings account, or the stock account, and let's add another method. Public void, or void, not the void, but double get value. Now, what is the value of this stock? Return this dot number of share price times this dot number of shares. Right? The same math that I was doing in the demo class, but I've relocated it here. Right? That's good encapsulation. If I had done it over here, that's bad encapsulation. I'm breaking encapsulation by ripping the guts open of this class, pulling out its insides, the number of shares and the share price, multiplying them together, and then I've got my result. The stock class should be responsible for stock things. Let me go ahead and get rid of this now. All right, s dot get value. There we go. All right. Now, we already got a function here that says get balance, right? But what if I wanted to treat them all as the same thing? In other words, I want to treat them all as assets, okay? So let me go. Let me try to do that. Remember what that was called? In fact, we've got a figure over here, right? Remember that all robins are birds, all ostriches are birds, but is a bird an ostrich, or is a bird a robin, and is a robin an ostrich, or vice versa, right? The covariance is what I'm looking at here. I want to take a robin and I want to treat them as a bird. I want to take an ostrich and treat it as a bird because I'm just going to treat them all as birds. Over here, I want to treat all my stock accounts, all my savings accounts, all my other assets, all just as assets. Asset A1 is equal to S. Asset A2 is equal to savings account. And asset A3 is equal to A. That way I can treat them all the same. Why would I want to treat them all the same? Eventually I want to put them in a list to take care of everything for me. Right? If I didn't treat them all the same, I would have to have a list for stocks, right? Stocks. And I would have to have a list for savings accounts. And I would have to have a list for another thing and another thing and another thing. Remember, eventually we are going to be adding another type of asset. And you can tell whether or not you have a good design if all you have to do is create this new class and you don't have to touch any other code. If you have to touch a bunch of other code, like add another list for whatever you're going to do, right? Eventually we're going to do crypto, right? Then it's probably a bad design. I don't want to have to do this over and over and over again. I want one list to rule them all. A list of assets. And I'll just call it my assets. There we go. New array list. Okay. And I need to bring these things in now. I can't believe that they're not already in there, but whatever. Come on, import and import. Now the reason that I want to do this is because I want to go into a loop and I want to add these things up, right? If I just had them not in a list, I would have to hard code all these things. But I'll go ahead and say my assets dot add A1, right? A2 and A3. And then I can go into a loop. What's my total, how much am I worth total, right? Double total value is equal to, started out at 0, and then iterate over all those assets for asset A, and I've already used A, so I'll go ahead and use the full word asset here. And in my assets, I will total value plus equals asset dot get value. Right? That's what I want, right? How much easier would it be to treat them all as the same thing, and they all have some value, and they all know how to do their own value calculations? For example, over here in the stock, a value for a stock means that it's the share price times the number of shares. For a savings account, it will be simply just returning the balance. So let's do that. Let's add another function here, public, double, get value. It's going to be the exact same signature here. It doesn't take any inputs, it returns a double, and it is called get value. Return this dot balance. Right? That's the value for a savings account. Specialized behavior. Now we can come over here to the demo class, and does it still work yet? No, not yet. I am treating all of these things as their superclass. Right? I am doing a covariance, right? That's what I want to do, but if I go to the asset class, do you see any function here called get value? No, they only exist in the subclasses. So let's promote that back up here so that everything has a get value function. Public, double, get value. There we go. Now my question here for a generic asset is, what's the value of a generic asset? The owner? That doesn't make any sense. The account number? That doesn't make any sense either, right? This has no real interpretation in the superclass here. I could return a dummy value, right? Return, in this case, 0.0, right? A generic asset has no real value, right? Or I could throw on exception, right? I could say throw new runtime exception, right? A generic asset has no value, right? And so you shouldn't have called that, right? We can do that. Or what I can do is even better than both of those things. I can say, I don't know. I don't know, right? This class is too general or abstract to determine its value, right? So what I'm going to do is I'm going to come up here and I'm going to introduce a brand new keyword called abstract, right? So this is now an abstract class. An abstract class can have what are called abstract methods. And I'm going to make this into an abstract method. Abstract. Right, there we go. And now the advantage here is that I don't have to answer that question. I don't have to return a dummy value. I don't have to throw an exception. I don't have to throw my hands up and say, I don't know. I could just leave it. I don't know, right? There is no function body anymore, right? The function body is defined by these opening and closing curly brackets, right? I don't know. It's abstract. This is too generic, too general for me to answer this question. Excuse me, for me to answer this question. Now that has some implications over in our demo class. Let's jump way up to the top here. When you have an asset class, or when you have an abstract class, you are no longer allowed to create instances of that class. That is actually a very good thing, right? For example, come back over here to the bird, ostrich, etc., right? Should I be able to create a generic bird, right? If I wanted to answer, well, how do they move? A robin moves by flying. An ostrich moves by walking because ostriches can't fly. They can actually run too, right? But if I just create this generic idea of a bird, would you be able to answer the question of how this thing moves? No. So we'll create that as an abstract class and not allow you to create an abstract bird. You can only create robins or ostriches. Just like over here, you can no longer create an asset class, or an asset instance, excuse me. Cannot instantiate the type asset. Okay, fine. I'll go ahead and get rid of it. Right? I can create stocks and I can create savings because they know how to handle themselves. They know how to compute their values. Right? And I'll go ahead and get rid of A3 now. Okay, there we go. So what is the total value of all of my assets now? Right? I'll go ahead and get rid of all that print statement and system.out.println total value. There. So it's going to be $120 for the stock times $10 per share. So that's $1,200 plus $100.25. I should get what? $1,350 or $1,325. Right? That looks pretty good. Right? All right. So let's take a look at what this looks like now as far as the UML diagram goes. And let's go over here to plant UML. Right? Now, unfortunately, I think that it's a bug, but come on. All right, let's just go ahead and double click on this. All right, there we go. All right, so the asset class is now the superclass. It's got all of these things here, and you'll see the get value, that's been italicized. That's the UML diagram way of saying that this is an abstract method. Right? Now down here it's not italicized because these are not abstract classes, they're concrete classes, right? And so they know how to compute their value. Right? We've got this. We've got the state here just as before. We've got all the methods that we care about, right? And this is a pretty good design. Right? Now, how do we know that it's a pretty good design? Let's come back over here, and now let's add a new asset class, right? Add a new asset class for crypto, say Bitcoin or something like that. Bitcoin is not the only crypto, right? But it is an asset. It's considered an asset. So let me go ahead and create a new class over here, and I'll just call it crypto. And by the way, you can do this in your when you're generating this stuff. The superclass will be the asset class. That'll automatically generate a bunch of code for me. Right, there we go. It has a get value method. Right? We need to determine that now, just as this to-do says. Right? We need to figure out what to do there. All right. So what defines crypto here? Number of coins. Right. So private double num coins. Right. And I now need to create a constructor using fields just as we did before. Right? Generate that. Right? It takes the account number, the owner, and the number of coins and sets all those things. Right? Now, what is its value? Well, it's not just the number of coins. This.num coins times what? If I had 1 Bitcoin, how much would that be worth right now? Nobody knows? Several $100,000, is it? What is it? Let's look it up. BTC to USD. USD is US dollar. So, not several hundred. So $70,000 it looks like, right? All right, well, that means that I need some more state here. Private double exchange rate. I should have done that to begin with. Let's go ahead and get rid of this constructor and let's regenerate it. And it'll take both of those things in now. All right, there we go. All right. So what is the value of this in terms of dollars? It's going to be this.numcoins times this.exchange rate. Oh, exchange rate. There. Okay. Now I only had to create this brand new class. Did I have to touch any of these other did I have to touch the asset class at all? Nope. Certainly didn't have to touch the stock class, right? If you already had a bird and a robin and an ostrich and you wanted to create a brand new bird, I don't know, a dove, right? Then would you expect to touch any of these classes? No, you just put it in this hierarchy and everything works perfectly without you having to touch any of that code. That means it's well designed. If, however, you ended up having to change the bird class to accommodate a new dove, right? Then that means that it was not well designed. If I had to touch the asset class here to create this crypto class, then it was a bad design. Let's go ahead and come over here and see it in action, right? So crypto BTC for Bitcoin is equal to new crypto XYZ for the account numbers. I'm still the owner here and say that I've got 10 Bitcoin, right? And here's my exchange rate. There we go. So now how much am I worth? Ooh, quite a lot. Oops, I didn't put it in there, sorry. I'm going to treat it as actually I'll show you here that you don't have to necessarily treat it like an asset on line 16 and 17. You can just go ahead and add it. My assets.add BTC. Right? Okay. And now I should be worth about $700,000. Yay. Much better, right? Okay. Did I have to change any of the code in this inheritance hierarchy here at all? No. But what does it now look like? I've got an asset, a crypto, savings, oops, not random data, but savings and stock. There we go. And let's take a look at the plant UML diagram. Right? All I had to do was create that brand new crypto over here, put it in the hierarchy, and I didn't have to worry about anything else. Right? It inherits everything from the asset class, all of its siblings in this family tree here, they're all independent, right, of each other, not of the parent, of course. Right? All right, good. So, review, or observations, I guess I should say. Let's see. First of all, the motivations. All right, here's observations. Observations. There we go. So why do we want to use inheritance? We've already seen that it's a good way to utilize code reuse. Right? Just as you would take a piece of code and put it into a function so that you can reuse that function, or you would take a piece of code and put it into a loop because you wanted to repeat that functionality, right? We're doing it on the class scale now, right? I've got functionality that's repeated in all of my asset classes. Well, that's fine. Create a superclass and promote all that common functionality up above so that you don't have to repeat yourself. I would have had to repeat owner, 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 and get owner, get owner, and get owner. And anytime I created a brand new class, I would have to add all that stuff in again, right? But using inheritance, I don't have to. I have code reuse. It provides a way to reduce redundancy because, again, if I had done it, I would have had a redundant owner across multiple classes. I'm only locating it now in one superclass. It provides a way to reason about and organize your classes into a hierarchy. Humans have a natural predilection towards creating order in the world. We do this all the time, like in the natural world, for example. Every living organism is organized into this hierarchy of organisms. What is it called? Kingdom, phylum, ... all the way down to species, right? And each one of those is most general, right? Kingdom, and then most specific down here is a species. We do this in business all the time. There's an org chart or organization chart. Up at the top, you have the CEO, and then you have managers, and then mid-level managers, then down here, the regular employees, right? We have hierarchies everywhere. Just why? Because we need to organize code. We need to organize things. It is well designed if the introduction of a new class does not break any other existing code. We'll talk about what this, like for example, what if over here in the asset class, instead of having subclasses, this is bad. I'm going to label this as bad, very bad, right? What if instead I had a type, private string type, right? Where the type was a string that represented savings or stock or crypto, right? Now down here, what would the get value look like, right? Now it would be if this dot type is equal, or that's not even how you do it with strings, right? Equals savings, right? Say I did it like this, then return this dot balance. I would have to take the balance and I'd have to promote it up here, right? Else if this dot type dot equals stock, right? Now I would have to take those two pieces of data, the number of shares and the share price, and I would have to put it up here, and I would start having what's called a God class that does everything, sees everything, knows everything. Return, dot, right? Now, every time I introduce a new class, now I touch this class. I have to add more variables. I have to add a bunch of if-else-if statements. Whereas before, if I was doing it correctly, I just have to create a new class, and whatever is relevant to that class is contained in that class. Right? So this is a badly designed version of this. And I'll roll it back to show you, and we'll talk about this later on. This is a violation of what's called the open-closed principle, and we'll talk about the solid principles later on. You should probably almost never see type, almost never. Okay. There are some exceptions to that we'll talk about later on. All right. Let's see. What happens if you have a well-defined subclasses but not so well-defined superclasses? For example, what if we were to do person, and then we want to do some media organization of some sort, and so they're a director and they're an actor, right? Or a writer or something like that, right? What if I wanted to create these three things all together here, right? Well, my first idea is that, well, a director is a person, right? An actor is a person, right? So maybe I should just put these into an inheritance hierarchy. And if I did that, I would have person over here. We do have person, right? Where is he? Right there. There we go. There's person. And I will go ahead and create a new class called director, right? That inherits from person. finish. There we go. Now, my first, I have to generate a constructor using the fields, so I'll just go ahead and add that constructor right here, right? And I'm done, right? Does this really add any value, first of all? Right? What have I added in the subclass that I don't already have in the superclass? Nothing. Right? I suppose that you could add a list of their films, and we'd have to create a film class that they've directed, right? Likewise, if I were to do this over here in a new class, and let's go ahead and make them into a writer or an actor. Let's go with actor. Right. There we go, and they are a person as well. There we go. And once again, it's not really adding anything to the design here. Right. Maybe you could, again, add a list of the films that they've been in or whatever, right? But why should I put these into an inheritance hierarchy? Is that well designed? Right? Writer, director, and person. There we go. Actor and director. Right? Well, let me come over here to my demo class and ask what happens when I create somebody like, I don't know, anybody know of a person who is at both? Right? Director, I don't know, I know, Kevin Smith. Right? Is equal to new director and Smith, comma, Kevin. All right, there we go. He is a director. He's directed many films, right? But he's also an actor. He always acts in his own films, right? Actor Kevin Smith, right, is equal to new actor. All right, and Smith, comma, Kevin. Now, in order to do this, I've had to create two instances of the same person, right? Whereas if I could have just said that they were a person, right? Person, Kevin Smith is equal to new person, right? Smith and comma Kevin. Right? All right, can I make that person into a director? I don't know. Can I? Can I take a bird and force them to become an ostrich? Remember, that's called contravariance, and it's not always safe. In fact, is it safe over here? Could I take director K. Smith and force the person to become that director? Yes, I could. I could say director. Remember, we had to do an explicit typecast when we did this with the example from Friday, which was not birds. What was it? A dog, a cat, and animal, right? And so Kevin Smith. There we go. So what is K. Smith at this point? We're treating them as their subtype as a director, but is that allowed? Right? That's a contravariance, right? And that's a class cast exception. Because in this case, they were a generic bird. Can you take a generic bird and force them to become an ostrich? Definitely not if, for example, they were a robin. Right? So does this make sense to put person, director, etc. into an inheritance hierarchy? In this case, I don't think so, right? And again, these are design decisions that you would argue with your partner or with yourself back and forth, right? Does that inheritance hierarchy make sense for everybody? No, because there are some people that are actors and directors, right? There are some people that are neither, right? They've never acted, they've never been in a film at all, right? And they've never directed a film, right? So why go to this? Why lock this into a hierarchy when you don't need to? First of all, there's no value added back down here in the subclasses yet, and in the you lock yourself into this rigid hierarchy where it has to be an actor, or it has to be a director, or it has to be a person. One of those things can't be the other, right? Except for, of course, a director is a person and an actor is a person. So sometimes you have these exceptions where it doesn't really make all that much sense. Here's another example. I'll go ahead and close all of these, and then we'll come back. All right, there we go. A rectangle, a shape, and a square. What should the relationship between these three things be? Is a shape a rectangle? Not necessarily. But is a rectangle a shape? Yeah, definitely. What about a shape versus, or a rectangle versus a square? Is a rectangle a square? No, but is a square a rectangle? Yes, it just has all four equal sides. So what I've done is I've put this into an inheritance hierarchy that looks something like this. Shape rectangle, square. A square is a rectangle. A rectangle is a shape. But now let me try to work with this now in the demo class. Where's my demo? All right, there we go. I'm going to go ahead and create a square. Square S is equal to new square, right? And it's of size 10. Right, so it's a 10 by 10 square. I need to import this. There we go. And you'll see what it looks like there. And I've already used S, so I need to rename that. But otherwise, it takes the width. Then it calls the rectangle class above it, providing a width by a width. In other words, it's going to be a square. Same width, same height. Right? I've already got a demonstration here. I don't need that demonstration over there. Right, there we go. Right, I've got it right here. Right? So I've created a square, a 10 by 10 square. However, my functions above that I have inherited allow me to set the height and the width. Right? If we take a look at, say, the rectangle over here, right? I've got height, width. I've got a get area, get width, get height, and set height. Right? So what's the problem with that? What is the width of the square before we get down to line 12? 10. What is its height? 10. And then I set its height to 5. Is it a square anymore? 5 by 10? No. But what is its type? It's still a square. It can't change its type, right? So when I output this, I'm going to get an area of what, 50? 5 by 10, right? Run it, yep, but it's still a square, right? What is this instance of keyword there? That's a thing that you should almost never use. There's one exception to that I'm going to tell you about there where you have to use it, but and we'll look at that here in a second, but that is checking to see whether or not S is an instance of a square. And if it's true, then it outputs that it's still a square. Okay? This is something called the diamond problem or the rectangle problem. Let's see. Yep, here's the rectangle problem, right? And there, I'll bring this over, right? So the rectangle problem is when your object relations in an inheritance hierarchy, when you define an inheritance hierarchy, you always have to follow that is a relationship. Is a person or is a director a person? Yes. Is a writer a person or an actor a person? Yes. But what about the relationship between an actor and a director? You could be both. You could be one or not the other, or vice versa, right? So it no longer makes sense when a person is both of those things. If you have mutable methods like setters, like set height, set width, that can change what an object is and violates that hierarchy, then that's a problem. And it's sometimes called the rectangle problem. Sometimes it's called the ellipse problem because you've got circle, ellipse, and shape, right? But I find thinking about rectangles and squares is far easier than ellipses, right? This is what's called a violation of the Liskov substitution principle. We'll talk about the solid principles towards the end, but that's the L in the solid principles, okay? All right. So, in other words, the takeaway here is your hierarchy has to be very well defined, right? And if it's not very well defined, then you end up fighting it, right? If not, you end up fighting it, like we would end up fighting the director, the actor, and the person, or you need to redesign it, right? And it needs to be well designed up front because if you have to go back and redesign it, guess what? That breaks all of your code, right? For example, when they created the Java collections hierarchy, for example, a list, a set, a map, all those kind of things, right? They really thought about the design, and this is just a small sample here of what it looks like, right? We'll talk about this in more detail later on with interfaces and abstract classes, but I mean, this was a well thought out hierarchy. What would have happened 25, 30 years ago if they did not have a well thought out hierarchy like this? They just did a hodgepodge, oh, we'll put that there, put that there, put that there. In the intervening 30 years, we would have been fighting that design. Because if they went back and they changed it, then that would have been backwards breaking, like 30 years of code is now broken. Right? Some languages do this, right? If you've done Python, right? Anybody done Python? You probably did Python 3. There's no way in hell you did Python 2. Why? because they did not have a well-designed language up front, right? For 20 years or so, they stuck with it, and they finally said, all right, we need to redesign some things to fix stuff, but it's going to break all the code from the last 20 years or whatever. So fine, we'll rip that Band-Aid off, and we'll go ahead and create Python 3, which is not backwards compatible with a lot of stuff, right? PHP is another example. PHP was so backbreaking. I think that they skipped like version 7 entirely and went to 8 and said, nope, we're not going to support backwards compatibility at all. Java is completely different. C is completely different. Those languages, they bend over backwards to make them backwards compatible, right? They do not want the last 30 years of code breaking, right? But thankfully, they had a well-designed hierarchy like this up front, right? And we didn't have to have any back-breaking kind of changes, right? All right, so some other observations here, right? Others, right? In Java, you can create an abstract class, right? What is it? Here we go. It's a class that you can inherit from. You can define methods and state, but you can also define abstract methods. Let's go ahead and tab that over, there we go. So it's a class that you can inherit from. You can define methods and state in your class, but also you can define abstract methods that have no default behavior. Basically, if you can't answer a question of this generic bird, how do they move? Or this generic asset, what is it worth, right? That should be screaming out to you, make that into an abstract class so you don't have to even answer those questions, right? You provide behavior in non-abstract subclasses. And as a consequence, you cannot instantiate, that is create, an instance of an abstract class, all right? Even if it has a constructor. In fact, it should have a constructor, but you can't call it. I mean, you can call it, but it'll be a compiler error. Initiate. Let me create spell checker there. Constructor. There we go. That's much better. Oh, constructor. There we go. That's why it's not doing it. All right. You can take that a step further, and you can have what's called an interface. Right. Not necessarily that you would want to do it for your project, but you'll definitely see it in this week's lab. An interface takes this to another level. An interface is a pure abstraction. It only has abstract classes. Right? It might have some state, or there's generally no state and no behavior at all. Right? For example, over here in this collections hierarchy, you have a progression from concrete classes down here that you can actually use, like an array list that you've used before, or a hash set that we've talked about before. Above that, you have what are called abstract classes, like we've seen with an abstract asset class. Above that, you have pure abstractions, right? So it's concrete, abstract, and pure abstraction up here, right? Oftentimes, these don't even define behavior at all, right? They define sometimes they define aspects or not behavior, but the nature of things, right? For example, random access over here. That's you can inherit that right down here to the array list. What that means is, like everybody's familiar with an array, right? You can jump to the 10th element in the array by just using an index, right? You can't do that with a linked list. We'll find that out later, but you have to start at the head and you have to traverse the list until you get to the 10th thing. A hash set or a tree set, you don't have order there at all. So neither of those two things is a random access. Right? Basically, if you can create an interface. Here's another example that's a little bit more concrete for us. Where is it? Inheritance. Nope. Here we go. Here's another example. Right? It's maybe a little bit more relatable, and it'll actually be relevant to your Lab 5 this week. Right? Suppose that we have employees. We have two different types of employees. An hourly employee and a salaried employee, right? An employee is payable, right? And so we put up here an abstraction, a pure abstraction of an interface that says we have to pay this person. But we also have a supplier over here, and you got to pay your suppliers, right? Otherwise, they don't supply you with whatever you're doing, right? So an employee and a supplier is both payable. An employee is a person, but a supplier is not a person. That's another company, right? But we have these things called interns over here that we don't pay them anything, but they're still a person. So I can create a hierarchy that looks like this and use interfaces to add in aspects or add in properties to each one of these things that says what they are. An employee and an intern is a person. By the way, an hourly employee is an employee and therefore they are also a person. An hourly employee is an employee and therefore they are payable, right? So you can make these things into a more complex hierarchy with multiple, you can see right here that we have what's called multiple inheritance. We'll talk about that later. But you can implement multiple interfaces and you can inherit from multiple interfaces, right? And it doesn't lock you into that rigid hierarchy. For example, what if I rethought my director and my writer and my actors, right? I could say, well, I could create a person or a director that has movies or something like that, and then I could say that they have that they are a person. I don't know. Maybe that's not that great. This one is much better as an example here, right? Where you want multiple aspects, but you don't necessarily want everything. Like every employee here is a person, but they're not all payable. We've got this intern over here that's separate from an employee that's not payable because we don't pay our interns or whatever, right? All right, so that's an interface. The way that you do this is through the keyword called implements, right? And we'll look at an example later on. It means that you can define and implement multiple abstract interfaces, right? And you'll definitely see a concrete or an actual example in your lab this week, Lab 5, that covers inheritance. Right? We'll do a little bit more on inheritance on Wednesday, and then we'll move on to polymorphism, the last pillar of object-oriented programming. All right, I'll see you on Wednesday then.